Hello everyone, welcome. In this video, I'm going to talk about the properties of definite integrals, and also I'm going to demonstrate how we can use the properties of definite integrals to evaluate the definite integrals. Suppose y equal to f of x and y equal to z of x, whose graph are shown here, are two integrable functions on the interval I containing the points a, b, c. So interval I is the interval from x equal to a to x equal to b, and also this interval contains the point c. So that means the interval I contains the point a, b, and c. In the illustration over here, c is the point which lies somewhere in between a and b. First property, integration from a up to a of f of x with respect to x is 0. You know that the definite integral from x equal to a to x equal to b is the area under the curve. When this b is very close to a, if b comes very close to a and overlaps with that a, then the area will be 0. That's why integration from a through a of f of x dx is 0. Next property, integration from b through a and integration from a through b of a function with respect to x, they are equal and opposite. That means if one is positive, the other one is negative, and vice versa. So integration from a through b and integration from b through a are equal and opposite. Similarly, if we are integrating the sum or the difference, f of x plus g of x or f of x minus g of x, then what we can do is we can find the integral of the first and then add or subtract the integral of the second. So it is integration from a through b of f of x plus or minus g of x with respect to x is integration from a through b of f of x with respect to x, then plus or minus integration of g of x from a through b with respect to x. Fourth property, if we are multiplying a function by a constant and integrating from a through b, what we can do is we can pull that constant out and we can find the integration of the function from a through b and then multiply the result together. So technically, while evaluating the integral involving a constant multiple, we can take that constant out and then evaluate the integral. Fifth property, integration from a through b. Whenever we are integrating from a through b and c is a point in between, when you integrate from a through b, that is the area under the curve from x equal to a to x equal to b. What we can sometimes do is we can integrate from a through c. So we can integrate from a up to c. So by doing that, we get the area from here up to here and then from c up to b. So a through c of f of x with respect to x plus integration of the function from c through b of f of x dx. So these are the 5 important properties of definite integrals. Example, suppose the function y equal to f of x and y equal to g of x integrable on the interval 2 through 7 with 2 through 7, integration from 2 through 7 of the function with respect to x is 10. Integration of g of x from 2 through 7 with respect to x is 5. Integration of f of x from 5 to 7 with respect to x is 5. And integration of g of x from 2 through 5 of with respect to x is equal to 2. We have to evaluate this. So first, what I'm going to do is I'm going to represent function f of x and g of x and these integrals using a diagram. Here for the function, the integration from 2 up to 7 is 10. That means the total area from 2 up to 7 is 10. And also here from 5 up to 7 is 5. So the area from 5 up to 7 is 5. We can label that area, that is 5. This area is 5. And also the total area is 10. So meaning of that is the area from 2 up to 5 is also 5. Because 5 plus 5 will make a total area of 10. Now if you look at g of x, the total area from 2 up to 7, from here all the way up to 7, the total area is 5. And the area from 2 up to 5 is 2. 2 up to 5, over here, the area from 2 up to 5 is 2. So this area is 2, total area is 5. So this area must be 3. Now we can use these two diagrams to answer these questions. So let's look at part A. Here we have a constant multiple, so we can take that out, times the integration from 2 up to 5 of f of x. Integration from 2 up to 5 is 5. So it becomes 5 times 5, which is equal to 25. In part B, it is the integration of the sum of two functions. So we find the integration of first plus the integration of second. Integration 2 through 7 of f of x. 2 up to 7 is 5 plus 5, that is 10. And for the second function, for g of x, 2 up to 7, for g of x is 2 plus 3, which is 5. That is equal to 15. Now in part C, it is the integration from 5 through 7 of 9 times g of x. 9 is a constant multiple. We can take that out, times the integration from 5 through 7 of g of x. 5 through 7 for g of x, it is 3. So 9 times 3 equal to 27. Now in part D, integration from 5 through 2 of 3 times f of x. 3 is a constant multiple. We can take that out, times it is the integration from 5 through 2 of f of x. 2 through 5 is 5. And here it is from 5 through 2. It is in the opposite direction. 5 through 2, it will be the negative of that. So negative 5, which is equal to negative 15. So this is how we can use the properties to evaluate the definite integrals. Integration of even and odd function, or evaluating the definite integral using symmetric properties. When we say symmetric properties, we are looking at the integration of even and odd function from certain negative value to the positive value with the same magnitude. So what I mean by that is we are looking at the definite integrals like these two over here, from negative a up to a. So you can see it is from negative a up to positive. These are opposite values. That's why it is called the symmetric property. First, let's talk about the even and odd function. When we say even function, a function y equal to f of x is even if f of negative x equal to f of x. This is how we check whether the function is even or not. For example, this function over here is even function. And always remember, the even function is symmetrical about y-axis. That means if we go from negative a up to positive a, and if we want to integrate this, then what we are doing is we are getting this area and also this area on the right, area on the left of the y-axis and area on the right of the y-axis. And we can clearly see these two areas are equal. So instead of integrating from negative a up to a, what we can do is we can integrate from 0 up to a. We can integrate from 0 up to a and double that. So that's why for the even function, integration from negative a up to a of f of x dx is 2 times the integration from 0 through a of f of x dx. Similarly, when we talk about odd functions, odd function is a function which satisfies this condition, f of negative x equal to negative f of x. And this is the illustration of the odd function. And if we try to look at the symmetric, if we go from negative a up to a, you can see that when you go from negative a up to a, and when we try to integrate from negative a up to a, we get little area below the x-axis, and we get the same amount of area above the x-axis. We get the same amount of area above the x-axis. So integration from negative a up to 0 is negative, and then from 0 up to positive a is positive. But these two are equal and opposite. That means when you try to add negative and positive, which are equal, the total result will be 0. So the definite integral from negative a up to a of this function will be 0. That's why for the odd function, integration from negative a up to a of f of x with respect to x is 0. So these two important properties are called the symmetric properties for evaluating the definite integrals. Now we are going to use the symmetric property to solve the definite integral. Example, evaluate the following integrals. Part A, in part A, we have the definite integral from -3 up to 3 of 3x raised to 4 plus x cubed dx. If we use the distributive property, it will be the integration of first term plus the integration of second. So -3 up to 3 of 3x raised to 4 with respect to x plus -3 up to 3 of x cubed dx. Now in the first integral, 3 is a constant multiple. We can take that out. And then we are integrating x to the 4, which is an even function from -3 up to 3. So integration of even function from -a up to a is 2 times the integration from 0 through a. So if we use that property, it will be 2 times the integration from 0 through 3 of x raised to 4 dx. Then plus this one, integration from -3 up to 3 of x cubed. X cubed is an odd function, and we know that when we evaluate from -a up to a, that will be 0. That means value of this integral will be 0. That is equal to 3 times 2 is 6. And when we try to evaluate this, the integration of x to the 4 is x to the 5 divided by 5, evaluated between 0 and 3. So now, in order to evaluate that, we can use the fundamental theorem of calculus. We can plug in upper limit and then subtract and plug in lower limit. If I plug in upper limit, I have to plug in 3. 3 to the 5 is 243 times 6 is 1458 divided by 5 minus, if I plug in 0, 0 raised to 5 is 0 times 6 is 0 divided by 5, that is also 0. So my result is 1458 divided by 5, which is approximately equal to 291.6. So that is the value of the definite integral given here in part A, and we evaluate this using the symmetric property of evaluating the definite integrals. Now let's work on part B. In part B, we have a definite integral from -pi/2 up to pi/2 of 4 cosine x plus 3 sine x with respect to x. Here is the graph of y equal to sine x from -pi/2 up to pi/2. We can clearly see that this is symmetrical about origin. So this is odd function. And this one is the graph of y equal to cosine x from -pi/2 up to pi/2. This is symmetrical about y-axis. So this must be even function. We'll be using that to evaluate this integral. First, what we are going to do is we are going to use the distributive property. That means we are going to write the integral of the first plus the integral of the second. So this is equal to integration from -pi/2 up to pi/2 of 4 cosine x with respect to x plus -pi/2 integration from -pi/2 up to pi/2 of 3 sine x dx, which is equal to, now for this one, 4 is a constant multiple. We can take that out. 4, we can take that out. And this is integration from -pi/2 up to pi/2, which is like integration from -a up to a of a cosine. Cosine is the even function. So it will be 2 times the integration from 0 up to pi/2 of cosine x with respect to x. Plus 3 is a constant multiple. We can take that out. Times the integration of sine. Sine is the odd function, and we are evaluating from integrating from -pi/2 up to pi/2, which is same as -a to a. Since this is the odd function, the value of the integral over here will be 0. 3 times 0, so the integration of second part will be 0. All we have to do is we have to integrate the first part. 4 times 2 is 8. Integration of cosine x with respect to x is sine x. And we have to evaluate that between 0 and pi over 2. We can evaluate this using the fundamental theorem of calculus. So we plug in the upper limit. It becomes 8 sine pi over 2 minus 8 sine 0. Sine 0 is 0. 0 times 8 is 0. So we are subtracting a 0. Sine pi over 2 is 1. 1 times 8 is 8. 8 minus 0 is equal to 8. So that is the value of definite integral given here in part B. And we use the symmetric property to evaluate this definite integral. This is the end of this video. Thank you so much for watching. I hope you find this helpful.